Hello everyone. Today we're going to be doing some indefinite integrals, some basic ones at that. We're going to be doing 7.5-ish problems. So let's get right into it. So the first one we're going to be doing is the integral of x to the 3 minus 1 over the square root of x plus x to the 5 over 2 and dx. Okay, so this is pretty simple. You can basically break this into 3 different segments. This is not absolute value. It's just demonstrating you can break it into 3 different places. So the antiderivative of x over 3 is pretty simple. It's x over 4 over 4 minus, well, this is x to the negative 1 over 2 because the square root of x is 1 over 2. Then having 1 under anything is the negative 1. So it's going to be negative 1 over 2 over 1 over 2. Okay, plus x. So you add 1 and then divide it by that. So it's going to be x 2 over 2 over 7 over 2. So you can simplify this, and it'll be simplified into x to the power of 4 minus 2 root x plus x to the 7 over 2 times 2 over 7, because you're just dividing by the reciprocal here. Pretty simple. Sorry, this isn't a minus. Alright, so pretty simple. Then we can actually take 2 out of all of this. So we can reduce it here, here, and there. So the way it would look is 2 over x 8, because 2 times that 1/8 is going to be a fourth, plus x to the 7 2 over 7 minus x. I've just moved the x just because it's a lot easier to say, plus c. I would call this simplified. You can simplify it if you want. It's just not simple again. 7x 4 plus x 8x3 minus 56 all over 28 plus c. So this is both correct, or both of these answers are correct. All right, number 2. So it is the antiderivative x over 3 times the square root of 256. Hey, that's pretty nice. X dx. So we need to do u substitution here. So I'm going to define u as 256, what's inside of here, minus x to the 4th. That means the derivative of du dx is going to be negative 4x3. Yes. Sorry, I'm just double checking my math here. Alright, so we can now do 1 to the 4th integral. We can take that. I don't know how I'm describing this well enough. Actually, no. I need to solve for dx. Sorry about this. Yeah, so dx is going to be 1 over 4x3 du. Okay, so now we can do what I was just thinking. I was thinking a little too far ahead. The integral of the square root of u du, because you can replace the x to 3 here, if that makes any sense. So you're kind of just, these cancel each other out, and so that's how you can get rid of the x to the 3. And so it just becomes 1 to the 4th times the integral of root u. Okay, this is pretty easy to take a derivative of. So, well, we know that the integral of u du, using the power rule, or the power rule, It's going to be 2u 3 over 2 over 3. Okay, so that means that when we times a negative 4, we get, yes, there's always a negative 4, oh my god. Sorry about this. I'm using notes and I'm just double checking. So we have 1 to the 6th, 1/6, sorry. Yeah. Okay. Yeah, negative 1/4 for some reason. Anyway, the integral of u du is equal to u 32 over 6. It's the same thing. That's what I wrote. Then we take, then we just insert u, this u here, and we get a negative 256 minus x to the 4th, 3 over 2 over 6. This is technically our answer, but you will get points off of it from pretty much any exam, unless the teacher is very nice to you, which they won't be because this is calculus. Over 6 plus c, because you need that constant in there. Sweet. So that's pretty simple. So, next problem. This is using the fundamental theorem of calculus, which I'll just write here. The integral of, no, I need more space. A, b, the integral from a to b of f of x dx is equivalent to big F evaluated, so it's just the function of b is equivalent to f of b times f of a. Pretty simple. It's what we've been doing. So taking the fundamental theorem of calculus, you can do the pretty basic math, so the derivative of the integral, which is the antiderivative, weirdly enough. Oh, this isn't, you know, these are new. You know, we now have something to plug in. And this is of cosine t d of x. Now, so how do we solve this? Well, something that's of good note is the answer of cosine negative pi. Use a unit circle, it's going to be 0. Why is that important? Well, that effectively becomes a 0, and so that means you have cosine of t. So that means that you have, so this is your f of b, I should recognize. So cosine of x, evaluated at x, this is our b here, minus, so this is all f of b, minus cosine of negative pi, which is our f of a. This is equivalent to 0, so you have cosine of x is equivalent, it's just equal, because this is your antiderivative sign effectively, and this is your derivative sign. So these effectively cancel out, but you're just evaluating these. Pretty simple. All right, let's just do another quick one of this theory of the fundamental theorem of calculus, as it is pretty important, and you will be tested on it. So let's do from 0 to x of 1 over 1 plus t squared dt. Again, these effectively cancel, so you're going to be evaluating them. So it's going to be 1 over 0, or 1 plus 0, minus, or, sorry, I'm thinking about it way too weirdly. It's going to be 1 plus x squared, you're just replacing the x here, minus 1 over 1. So, or this is a negative. And then this just becomes 1 over 1 plus x squared. All right, next problem. Number 4. So it's going to be the antiderivative of ln, the natural log of x, or not the natural log, just the log, I should say, not to confuse. So this again can be using u substitution. So for this, we want to get to the integral of u du. And what are we going to define u as? Well, we're going to define u as ln of x. Our derivative of u is going to be equal to 1 over x, and x dx, I should say, is equal to x du. Okay, pretty simple. So now we can just evaluate this, and the integral of u x equivalent to, well, it's just u. It's going to be equivalent to u squared over 2, and we just plug it in. You get ln squared of x over 2. That's our answer. Okay, might be a little confusing. Let's do another W substitution. There's other ways you can solve this next one, but this is a way teachers will like, and it'll pretty much always work for you. So, pretty convenient. So we're going to take the antiderivative of dx over x plus 3 times x plus 4. So you might be tempted to FOIL this. It won't make your life easier. So this is effectively equal to 1 dx, if you are interested in knowing that. Makes it easier just to think about it, I think, anyway. So it's going to be, so we're going to set our u to the larger of these values, which is going to be x plus 4. Du dx is going to be equal to 1. That means dx is equal to du. So that means in solving, the antiderivative is going to be 1 over u minus 1 u du. Okay. And then we can expand the factor using 1 over u squared. So that means it's going to be equal to 1 over, or the 1 over 1 minus 1 over u times u. We haven't made this simpler. Uh-oh. So that means we do another u substitution, but in this case we're going to be using v. Just makes it easier. So we're going to set v as 1 minus u. That's the inside of this. Okay. So that means our dv du is going to be equal to u2. That's where we get that from. And then du2. And so that's going to be equal to yes. So that means we can solve this now. It's going to be 1 over v dv integral of, which is equivalent to ln v. Okay, so now we can just start plugging stuff back in. That means it's going to be the ln of 1 over u. Okay, and then we plug in u again, and so this becomes ln of 1 minus 1 over x plus 4 plus c. Bada bing, bada boom. We have our answer. Okay. So now 2 more problems. Would I say these are harder? Yes. No. So let's do number 6. So we have dx over function effectively 4 minus x squared. Okay, pretty simple. Again, u substitution. Getting pretty used to this. It's a very usable and important skill here in calculus. So that means, 1 over 2. Sorry, I was checking my math. So this means that dx is equivalent to 2 du. Okay, so that means we can then calculate this to be 2 over 4 minus 4u squared du is equivalent to the integral of 1 over 1 minus u squared du. Oh, this is an important form. This is equivalent to the arcsine of whatever this function is. So that means it's going to be the arcsine of u. Now we just plug in u. Which is x over 2. And we have our answer, plus c. Okay, last one. I'm just going to do it on the same page. Alright, so this is an indefinite integral. So we have antiderivative evaluated from -1 to 1 of x squared plus 1 to the power 2 dx. So we can actually FOIL this, and that's the way we're going to do it. So x to the 4 plus 2x2 plus 1 dx, just using a FOIL method. Pretty simple. I still have to write down FOIL. Typically, for that, it's pretty simple. The form is pretty simple. It's just x to the higher power times 2 plus whatever last two are multiplied. Okay, so we can now actually just break this into a bunch of parts. Luckily, so it's just going to be x4 plus 2. So we can take the 2 out of this. X squared dx plus the integral of 1 dx. So we just can evaluate all of these. Pretty simple. So x to the 5. I don't know why I just wrote that. 2x to the 3 over 3 plus x plus c. Okay, so we now have this, but we all need to evaluate it from -1 to 1. Okay, -1, or x to the 1 over 5 plus 2 over 1, 3 plus 1. We don't need this actually. I don't know what I'm thinking. Minus, so this is all together. Minus the same thing, just negative. So this is going to be x, or why did I write this? This doesn't make sense. It's 1 to the 5th. -1 to the 5 over 5 plus 2 to the -1 power 3 over 3 plus 1. Okay, so this is just going to be, so we can simplify this. That's 1 over 5 plus 2 over 3 plus 1 minus -1/5 plus -2 over 3 plus 1. Oh, look at that. They all cancel out. Bonk, 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 bonk. So that means that the area between these two segments, I'm just going to draw a function to do an example of this. It's not the real one. I mean, you could look at a sine function. So that means that if you looked at the area from here to here, that the area below and the area above the curve are equivalent and therefore equal 0. Notice how this is an equal distance. Thank you very much for watching. Hope you learned something. Sorry about my small mistakes. Have a good one. Bye-bye.